Last time we spoke about analysis of variance. The principle of analysis of variance, where you look at your variance due to your treatment, due to your reps, due to interactions if it's a factorial, and so forth. And the principle of analysis of variance is the same for all the different designs. The designs are essentially aimed at maximizing your treatment effects and minimizing your error or your residual effects. And your residual effects, as we said, generally come from variation in your trial layout or the field that you have or something like that. So you either go for a randomized block or you go for a split plot. Split plot normally, if you want to look at interactions between a number of factors and you're trying to minimize the size of your layout. Then the lattice square and augmented designs and things like that, aimed at optimizing your resources and minimizing variation. And that principle stays the same with all those analyses. I want to, just before we move on to regression and correlation, just mention in passing a specialized analysis of variance. They call it the Emmy Analysis, or Additive Main Effects and Multiplicative Interaction Analysis. And I can never remember that name. I can remember Emmy. Okay. And the whole purpose of Emmy is, Emmy was developed, it's an integration of principal component analysis and analysis of variance. So if you look at the top part here, it's a straightforward factorial analysis. You've got your genotypes, you've got your environments, you've got your interaction. And the purpose of this analysis is to look at the stability of genotypes over environments. So if you've got multi-season analyses, which I think you all have, you have different environments, you have the genotypes, and you want to look at the stability of the reaction over the environment. And that's where Emmy becomes very good, because what it does the environment genotype interaction analysis, but it also then works out principal components. And just very briefly, to show you what that does, based on the principal component or the IPCA score that it works out, you can work out how stable or unstable the genotype response is over environments. So here I've got different localities where I did trials, and there are, if I remember in this trial, there were 67 entries, and the IPCA scores, this is deviation from the mean. In other words, that side would be less disease, that side would be more disease relative to the mean. There you have an IPCA score, which can be positive or negative, and depending on the deviation from the zero line there, it's an indication of how stable the genotype is over environments. You can then also plot your environment scores, and you can see that some genotypes tend towards that environment, some genotypes react to that environment, and you can start getting some idea of the adaptation of the genotypes to certain environments. You can get an idea of the stability of response over environments, and especially for those of you who are doing multi-location, multi-season trials, this would be a useful analysis. The closer the genotype falls on this zero line, the more stable the response over seasons. So ideally what you want are genotypes like this that are stable over different environments and also giving you less disease than the rest. Okay. So Emmy analysis would be worthwhile looking up, and I think it would be relevant for the kind of trials you doing. Sorry, I just wanted to check. Okay, I'm not going to. There are going to be some additional points in the notes that you are given, but basically, just to conclude the logic of analysis of variance, the Purpose of analysis of variance is to test differences in means for groups or variables for statistical analysis. They can detect interactions between variables. They can test complex hypotheses about reality, between treatments, within treatments, between treatments, environment, temporal, whatever variables you want to use. We know that there are many variations in experimental design, many possibilities if applied correctly. And then the main point is with any inferential statistical procedure, it's important to state the hypothesis of interest clearly before undertaking any statistical analysis. And I want to emphasize that one again. When you're doing an ANOVA, when you're looking at your trial design, be sure that you know what questions you want to ask before doing the trial. Okay? And your stats and your trial layout is then done according to that. Now tomorrow I'm going to spend a bit of time working through 2 or 3 examples so that you can actually see how the stats is applied to the answering of the questions and the kind of conclusions you can reach from the statistical outputs. Okay, so that just to then wrap up in ANOVAs.